This video is going to walk you through part C of the classifying critical points AP problem. So part C says the function h is defined by h of x equals g of x minus 1/2 x squared. Find the x coordinate of each critical point of h from -7 to 5 and then classify each critical point as the location of relative minimum, maximum, or neither, and then explain your reasoning. Well, the very first part, it says find the x coordinate of each critical point of h. And so remember, a critical point occurs when the derivative is equal to 0 or undefined, but in this case, h prime of x equals, well, the derivative of g is g prime of x, and then the derivative of 1/2 x squared is just equal to x. So a critical point, remember, is when it equals 0. So I'm going to set this equal to 0, and then I'm going to simplify it so I can see exactly what that relationship is. And so this is telling us that when g prime of x equals, not 0, equals x, then that is where h prime is going to have a critical point. So we need to find the points where this occurs. Well, we're given the graph of g prime. And so when g prime of x equals x, that's the same thing as saying when your y value equals your x value. So if I draw a dotted line as best I can, you can already see one of the answers. One of the answers is when x equals 3, because 3 is the x value and y is the x value, which is g prime of x. The other point that we need to find is the one that is on this semicircle, so right there. And you don't want to estimate and you don't want to guess. There is a way to algebraically find that. So I need to find the equation of that semicircle, and that's going to be my equation of g prime of x. Well, remember, x squared plus y squared equals your radius squared, so that's 4. I'm going to get y by itself, so I'm going to subtract x squared from both sides, and then y equals the square root of 4 minus x squared. Well, this is my g prime of x. And so I'm trying to figure out when g prime of x equals x. So I'm going to plug in x here, and I'm going to solve for x. So I'm going to square both sides. So I get rid of that square root, and so I get x squared equals 4 minus x squared. I'm going to add x squared to both sides, so I get 2x squared equals 4. Divide both sides by 2, and so then we get the other x value. The other critical point is the square root of 2. So right here, this is the square root of 2 and the square root of 2, and then we have 3, 3. So those are our two x coordinates of the critical points of h. And now we need to determine if they are relative minimum, relative maximum, or neither. And so what I like to do is set up an interval. And so I am going to go from 0 to the square root of 2. Then I'm going to go from the square root of 2 to 3, and then from 3 to 5. Okay. And so I want to check the sign of h prime in each of these intervals, because that's going to help me determine, is my function going from increasing to decreasing or decreasing to increasing. So I know the square root of 2 is about 1.414, and so I'm going to find h prime of 1, and I'm going to plug that in, and that's going to be g prime of 1 minus 1, and I'm plugging it into this derivative equation right here. And so g prime of 1, when I plug 1 into my square root of 4 minus x squared, I get the square root of 3 and then minus 1. Well, what I know about this is that it is positive. And so that tells me h is increasing on this interval. Okay, sorry, my table is going to be a little off. So then now I need to figure out a point that's in between square root of 2 and 3. Well, this is about 1.414, and this is 3, so I'm going to pick 2. So h prime of 2 would be g prime of 2 minus 1. Well, when I go up to my graph, well, here's g of 2, which is 0, minus 1, I get negative 1. Well, that's less than 0, so that tells me h is now decreasing. So I know that because at the square root of 2, my function changes from increasing to decreasing, the square root of 2 is a relative maximum since h prime changes from positive to negative. Make sure you write out all the words, don't use abbreviations. And then I need to figure out what's going on after 3. So we know that In this interval, our h prime is negative, and so we need to find out what's happening over here. So I'm going to do h prime of 4. Well, this would be g prime of 4 minus 4. G prime of 4 is equal to 1, and 1 minus 4 is a negative, so less than 0. Well, since my h is negative, h is decreasing. And so since h goes from decreasing to decreasing, that tells you that 3 is neither a relative max or a relative min. And that was the first derivative test that we used.